décollage. Fantastische blue Amerika.
Black holes are some of the most elusive objects in the universe. They can form when a massive star collapses under its own weight. Because they are very dense, the gravitational pull of black holes is so strong that nothing can escape, not even light. Thus, they have long remained black and mysterious. But now, thanks to ESA's and NASA's X-ray observatories, XMM-Newton and Chandra, astronomers have a much clearer picture of where black holes are and what they can actually do. And that can be quite dramatic. It all started a few years ago when the German X-ray satellite Rosat detected a burst of X-rays from the direction of a distant galaxy, until then unknown. The burst was so violent that the X-ray energy from that galaxy, called RxJ 124211, suddenly rose dramatically. What puzzled Dr. Stefanie Komossa of the Max Planck Institute for Extraterrestrial Physics near Munich was the shocking contrast between the tranquil appearance of RxJ 1242, shown by normal optical telescopes, and the fierce blasting seen by Rosat's X-ray eyes.
Most galaxies emit X-rays, ours too, but usually at a weak and constant level. Here, however, the story was completely different. This galaxy suddenly flared up in X-rays and became thousands of times brighter in X-rays than all of its millions of stars taken together. Yet, in visible light, it still looked like a perfectly normal galaxy, so that was quite puzzling.
Still, Komossa and her team didn't know precisely in which part of the galaxy the X-rays originated. But the exquisite pointing accuracy of NASA's X-ray observatory Chandra gave them a definite answer. The X-rays came straight from the galaxy's center. Then a thought began to form in Komossa's mind. Could this burst of X-rays be just the last cry of a star ripped apart and swallowed by a massive black hole? The gravitational pull of a massive black hole is enormous. If a star like our Sun happens to venture too close to such a monster, it can easily be stretched and torn apart. Differences in gravity acting on the front and back of the star eventually disrupt it. Like an explosion, most of its gas, shown here in red, is ejected and manages to escape. But some of the gas is trapped by the gigantic pull of the black hole and slowly spirals in, forming a gas disk. The presence of a disk was the signature Komossa was looking for.
If our theory was right, there had to be a disk of gas around the massive black hole, made up of the debris of the disrupted star. In these extreme conditions, the gas is heated to millions of degrees, emits strong X-rays, before disappearing forever, swallowed by the black hole. We had to be quick to catch the burst of X-rays before it would fade away. There was only one way to proceed, which was pointing at this galaxy, the XMM-Newton observatory of the European Space Agency.
Launched in 1999, ESA's XMM-Newton is the most sensitive X-ray observatory available today. Its observations of the X-ray emission from RxJ 1242 revealed the unmistakable signature of a slowly fading gas disk. For Komossa and her team, this was the much sought-after answer to an outstanding question.
For the first time, we now have very strong evidence that massive black holes can tear apart whole stars and swallow these stars. This finding also helps us to understand how black holes are fed, that is, how they grow to their sometimes enormous masses. The one in this galaxy has about 100 million times the mass of our Sun. So we now have a much clearer picture on how black holes evolve and how they affect surrounding stars. This is quite an exciting moment for us.